Welcome to lecture number 20 of part 1. I'll remove it now, not required. Now, we will start numericals. First make a note. See, before you start anything, first make a note. When we find moment of a force about any point, you should write all these things. Suppose you want moment about how you write your problem. See, suppose you want moment about any point. If the force is horizontal, directly answer is that force into the perpendicular, that is vertical distance. This I thoroughly told last time. Or if the force is vertical, then the force into horizontal distance, perpendicular distance. Very, very easy. But so many times in mechanics or somewhere you get inclined forces. I will tell now only, if inclined forces are there, the best option will be to resolve them by the components so that one of them is horizontal, other is vertical. Then you can happily find the moments. There is no problem. But you should know the basic calculation. That is, if a force is inclined, as per basic theory, how force into perpendicular distance. For inclined force, perpendicular also will be inclined. See, last time I explained. You can avoid all this confusion by resolving. But knowledge is important. I will tell you why. Suppose tomorrow you go to an interview somewhere. They want a moment of an inclined force about a point. They will give the pen and the calculator for you. You write, I am resolving component. He may tell, you don't resolve. I want to test you whether you know correct basic concept or not. What is the basic concept? You have to tell what? You should not tell components all. Force multiplied by perpendicular distance. Okay, find that perpendicular distance and get the moment. Then you can't tell that I cannot do. Oh, why? You don't have that much mathematical background. They will tell that way. Or in the competitive examination, sometimes they will ask you, what is the perpendicular distance from this point to line of action of the force? So question can come that way. And also, when you learn everything systematically. Easy options I am giving. Therefore, what I will do is, now today's class starts, I will consider first inclined force. How to find moment about any point. Numerical value. See now, make one more note. Suppose there is a point here, any point O, about which you want moment. Inclined force, you should give one point through which it is passing. See, now, suppose you draw a vertical line here or horizontal line here. If the inclined force passes through a point, given point, which is known to you this way, then see, moment calculation is very, very simple. Simple triangle, you get the perpendicular. It does not look perpendicular. Or if the inclined force is somewhere here, perpendicular, you can calculate. That is provided if you know the point where that force cuts a horizontal line or vertical line connected with the point O. See, this point is connected with the point O vertically. This point is connected to the point O horizontally. But if the inclined force is given this way, see, suppose this point is given for you. That point is it is not connected with O either vertically or horizontally. Then some trigonometric calculation is there. This is the toughest one. So toughest one is, see, question here. Find moment of given force about A. Both are same questions. See, both the questions 80 Newton force. This height is 200, this is 160. Here also 200 millimeter, some unit. 200 millimeter, 160 millimeter. A, B, C, A, B, C. The only change is that this both are inclined forces. This is inclined with vertical at 20 degrees. This is inclined with vertical at 60 degrees. Somebody will tell, sir, if you can do that one, you can do this one. No, there is some difficulty. When you go to trigonometric calculation, changes will come. There is a reason for it. I will explain to you. So, such a hurry, you should not come to a conclusion. Someone will tell, I will replace 20 by 60. No, see what happens later. No, wait for some time till I solve. These two questions I will solve first. Question 1, question 2. No, for both the questions, make a note. See, class, for both the questions, you know a point C through which the force is passing. Here also, point C through which the force is passing. You want moment about A. See, moment about A required. See, moment about A required, moment about A required. That point C is neither connected horizontally nor vertically directly with the point A. Oh, therefore problem. But same question, if 80 Newton is acting here, it is very simple. That I will do second round. Suppose the 80 Newton is acting here, that point is connected to A by a vertical line. Or if that 80 Newton is acting somewhere here, see, suppose along this line, again you can tell that point is connected with A horizontally. So here, point C is, when you join point C to A, if it is a horizontal line or vertical line, if you join B to A, it is a vertical line. Or some point here, if you join to A, horizontal line. But when you join the point C through which force is passing with the required point A, it is an inclined line. So therefore, this is the maximum among the difficulty cases, most difficult. I will completely make clear. But of course, this question can be solved very easily by resolution. That we will keep option 2. Option 2, easy option. Later, everywhere go for that option only. This is only for understanding. Start now. First solution. Question A, question B, both I will solve simultaneously. See. Question A, write some statement. We want moment about A. Here also, what statement I am telling for A, same statement you write for this question. Sorry, what statement I am giving for question 1, same statement you write for question 2. If you want, write once again. We want moment about A. The force is inclined force. See, force is inclined force. Therefore, to get moment about A, from A, we need perpendicular distance to line of action of the force. Let that perpendicular be H. Now, draw one more sketch neatly. This sketch is to get perpendicular distance. So I write here now. See, this is your option 1. Option 1 means as per basic definition. As per basic definition of moment. Definition of moment. What is the basic definition? Force into perpendicular distance. Here also, what I am doing is option 1. Option 1, right here, same option. As per, now I won't write, basic definition of moment. Write once again. Basic definition of moment is force into perpendicular distance from that point to line of action of the force. Resolution all comes secondary. Okay, start now. Therefore, for both the questions, from the point A to line of action of the force, you require perpendicular. Okay. So therefore, what you do is, this 80 Newton force, see, in red color I am showing that one, that force I am showing red color. So what I will do is, that line to be extended. See, if you are perpendicular from A, this line to be extended. Now see, something you are right in the class now. Suddenly doubt will come. See, when I extend that line, will it come, that line will go this, see, from this vertical line. Will that line will come somewhere below A? Will it come and cut this line somewhere below A or somewhere above A? Depends. See, if the force is too steep, see, if the force is like this, oh, surely below. But if the same force is like this, it will cut above. So doubt comes. Unless you clarify that one, you cannot go for geometry. So what to do is, therefore, stop. Before going there, you find this angle. See, A, B, C. You find this angle. Say theta. Some angle theta. This theta equal to, see, you can see here, this is 160, this is 200. Unit I am not writing, every linear is millimeter. Okay, I will write 160 millimeter, 200 millimeter. Some will tell unit written. Tan theta equal to 200 by 160. Calculate tan theta. I already calculated that one somewhere. I forgot where. I wrote all the answer there so that I can save the time. And if any mistake is there, I can rectify immediately. Calculation mistake. 200 divided by 160 equal to shift tan inverse answer. 51.3402 degrees. 51.3402 degrees. I am going more accuracy. Remember, calculated. Round off. Round off means calculated. 51.3402 degrees. Same way, calculate here also. Here also it will come same answer. Why? The force is inclined, but ABC remains same. 51.3402 degrees. So this is 51.3402 degrees. Calculated. Okay. Now do one thing. See here. When you join this line, this is making angle theta. See. Suppose I put the point C here. I will extend this line and extend this line here to understand correctly. Here also, just to understand, see, I will extend this line and extend line. 100%, if this is theta, this is also theta, guaranteed. If this is theta, this is also theta. Now, here, they told this angle is 20 degrees. See, they told this is 20 degrees. If that is 20 degrees, this angle is 70 degrees. Here, they told this angle is 60 degrees. If that is 60 degrees, this angle is 30 degrees. Remember, calculated value not given in the question. Someone will tell, sir, what, sir? We don't know that much. I know people, sometimes students will ask, sir, how you got 70? I will tell, go back to that standard, maybe third or fourth standard, when someone taught you between this is 90 degrees. Got it, sir, yes. See that, at least common sense. This is 90. If this 20, 70, 20. Now see here. This angle theta is, now you have to write in the class. I will dictate. For both question I will dictate. You should write. Those who are serious, only in the notes I will write all these things. Start. See, this one. If I join C to A, this line makes angle of 51.34. But the force is making angle of 70 degrees. See, this is 70 degrees. Actually, little out of scale. It should have come little more stiff. Okay. I'll do one thing. I'll make it pull little more stiff. Okay, little bit. For a while. See. This is the force. How much force? 80 Newton force. I use red color for force. Force red color is not required. I leave it 80 Newton. 80 Newton. See. They told this is 20 degrees. This is 70 degrees. Therefore, see, this line when you extend, this angle also is 70 degrees. 70 degrees. Here, if you extend this line, when you extend here, see this is 60 degrees. They told this is 60 degrees. This is 30 degrees. If you extend, this also is 30 degrees. You write procedure. Come to the inner side and mark the angle. Then, now your line, this line, if you join C to A, it is making angle of 51.34. See, 51.34 here. Oh, therefore, this line will come further this side. Oh, it will come further this side, further this side, further here. See, it will, when you come here, it will come not up to here. See, this is, what is the angle? 51 degrees. This is 70 degrees. Oh, it will go further, 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 further. Let it go, no problem. Come. You tell it. Come. Up to wherever you want to come. Okay. It will come up to here. Okay. Somewhere here it will come. Here. Okay. This is for this question. This is the point A. Okay, now here. See. Once again, this angle is 51.3 out of scale. Sorry, it should have been a little more stiff, out of scale. 51.34 degrees. This is 30 degrees. This is 51.34 means, see, somewhere here. The line C to A joining will come somewhere here. Oh, this is lesser angle. So when you extend this line, this will cut. See, this will cut the AB line somewhere here. Whereas this will cut, this line will cut your AB line after extending the line. So You have to extend this line, then only cut. Let that intersection point be D. D. Right here. Let the point where, which line? The line of action of the force cuts the vertical line through B. If required, extend it. Let it be D. Here it will cut after extension. Here it will cut before extension. Okay. Now do one thing. Happily, from the point A, what you do? Drop perpendicular H. To this, from A, drop perpendicular H. This is should be perpendicular. Okay, now this way. Okay, done. Perpendicular H. From right here, from the point A, drop, you right here, from A, drop perpendicular H to line of action of force. This statement you have to write for both the questions. Both the questions. See here. Here, when you see the line is coming here, the force is coming here. Now perpendicular will come this way. This is perpendicular H. Okay. Now that point where it meets perpendicular A, B, C, D, let it be E. The point where perpendicular meets that line is E. Okay. Now these two are over. Major construction is over. I hope high school level mathematics, so this should be clear. Nobody can tell this is not clear, sir, confusion is there. Not allowed, because such a simple one you should be able to understand. Okay, now I will remove all unwanted now. See, now remember, you do not require this sketch. I remove this sketch. This sketch is required only to decide whether that line cuts this vertical line below A or above A. Once that is over, this is not required now. Remove it. This is not required. Purpose is over. Here also, this is not required. Purpose is over. Purpose is over. Now see correctly how to get H. Once you get H, question is over, because why over? Once you get H, moment equal to force into H. Okay, start. Now, right here. Now we this also I want more space now for both questions. You solve both separately, not this way. You solve the first question. After completing, observing the class, once again solve it. Second question. Okay, now to get H here, to get H. Okay, I'll do one thing now. I'll first finish this question, then go there. See, to get H, see, if this is 70 degrees, you should write everything. Angle made at D will be 100% 20 degrees. Why? See, this is 90, 20 degrees. Remember, not given, decided by us. You should write. You should write all those things. I cannot write each and everything. Or if you want, this angle will be 20 degrees. This angle will be once again 70 degrees. Your choice. 70 degrees. See? See? 70 means right angle triangle. 20, 70. Okay. I will come later. Now, to get H, see here. Consider a triangle, right angle triangle, ADE. ADE, right here, which is right angle triangle. Or I will do one thing, small dot I will put, this triangle, see, this triangle. There, to connect H with AD, this line, okay, then you can write what? Sin 20 equal to H. H is the opposite side. See, this is 90. For this triangle, this is the hypotenuse. Why 90 degrees here? Sin 20 equal to H divided by AD. Okay. Or you can do one thing, your choice. You can write cos 70 equal to, both are same answer. Cos 70 equal to, which one? Sin, if you use cos 70, what happens now? Once again, H divided by AD. That is, both are same. See, why? When you sin this angle, sin 20, H is the opposite. hypotenuse. When you 70 degrees, H is adjacent. So, or you know it, cos 70, sin 20 equal to cos 70. So, this is not required. One of them is sufficient. Okay. Now, we need, now to get the value of H, we need AD value. What is AD? From A to D. How to get it is, see, how to get AD. For that one, consider the triangle, full triangle, BCD. Full triangle, BCD. See here, what I am doing. See, a light line, I will show it now. See. You write, if you want to write one more sketch, what is there? Write one more sketch. Wait, here. You use either this angle or this angle. See, if I use this angle, see, this side is known for you. This is known to you. And this is 70. What you can do? You can use, see, this full, this is not known. This is known. Which one is how much? This is 160. This is 160. So this is known. You want which one? BD. We need AD. Okay, you need AD. Okay. One minute here. To get AD, right here. To get AD, first get BD. First get BD. Why? Because once you get to B to D, B to A is known to you, 200. See, you write there. B to A is already known. See, this is 200. This is already known for you, 200. So, if you want AD, first you get to BD. To get BD, consider triangle BCD. Those who want to use this angle, for them, 160 you connect. How much? You get it. Tan 70 equal to, tan 70 equal to BD divided by BC. BC, but BC equal to 160. See, you know, BC equal to 160. Therefore, you get the value of BD. BD will come, I already calculated, 439 point, to save the time, 439.5964. Why waste time? I already calculated it. Okay, over. Now, or you can do one thing, see, or if you do not want 70, you can use 20 also. Tan 20 equal to BC divided by BD. BC is 160, substitute, this also will give you same answer. My guarantee. Substitute, your BD will come, here see, here it is, how much? 160 into tan 70. Here 160, if you write here, what happens? BD becomes 160 divided by tan 20 it becomes. Okay, check the answer. 160 divided by 20, actually waste of time. 160 divided by tan 20. Actually I am wasting time. 439.5964. Okay, wasted. Over. Now you got the value of what? B to D. Remember, therefore, I am going that side, space I am using. Therefore, what we want? We want the value of H. I told to get H value, you require A to D. Now, BD is known. I told you require which one? AD. Therefore, AD equal to, A to D equal to B to D minus B to A. B to A. B to A is 200. Why? See the original question. See, I am writing this side now, not for this question. Space, I will come to this question later. 200, original question. Right. Therefore, this I am writing only for this question. Therefore, what do you require? You require which one? AD. Therefore, BD, just now we got how much? 439.5964. Just now we got. Therefore, your AD equal to, why calculate? 200 less. 239.5964 millimeter. Okay. Once you get AD, therefore, substituting in which one? See, Sin 20 equal to, already written, see, sin 20 equal to h divided by AD, h divided by AD, AD is already equal to, just now we got how much? 239.5964. So many online classes I have seen people writing. Therefore, h equal to 239.5964 into sin 20. What? You are primary school students. You can make out. Therefore, we got the important answer. What is h equal to? It is answer 81.9468. 81.9468 millimeter is the value of h. Over. Everything is over. Now I will remove all these here so that I can go for moment calculation. See here correctly. How to find moment now? We got h. Everything is over now. This full I am removing. Okay. Full I will remove. H we got. Therefore, moment of that 80 Newton force about A equal to 80 into, see here, about A equal to 80 into perpendicular distance h equal to 80 into h how much? 81.9468 equal to 80 into, I already calculated there. Why I am wasting time? 6555, I already calculated. 6555.744. 744 Newton, force in Newton, distance in millimeter, and direction required. This I told you clearly. Hold the pen at A. I will not explain more. See, load is this way. It is clockwise. See, here it will become anti-clockwise. That much clockwise. So I will write here now one note. Therefore, note by basic approach, I wrote here basic definition. By basic definition, just to remind you, definition, answer is definition, moment about of the force 80. Moment about A is how much you got? 6555.744 Newton millimeter clockwise is the answer we got. Why I am writing? Because I am going for option 2. Option 2 also same as the answer has to come. Okay. Now this question fully over. I will go to that question now. Then I will go to option 2. Okay. I will remove this one. This sketch is not required now. Option 1 over. Remember, for question 1, option 1 over. What is still pending? Option 2 pending. I will tell you later. But anyway, let me finish question 2 also by option 1. Why? Trigonometry. Okay, start. Question 2. All I explained here. See, this all I explained for you already. Which one? Why this comes this way? All I told you. Here also. See, sorry, this also is an old question. That is old question. I should remove it. Old question. Okay. Okay. Now, I told if you join this point here, angle is some 53 something. This is 30. Line comes here. Your perpendicular. Extension of the force cuts the AD line at the upper point D. Draw perpendicular E. This is same as last time. Now see. Now also see here. Consider this triangle. Now see. Now to get moment of 80 Newton about A by basic definition, right here, basic definition, we need H. We need H. H is perpendicular from A to line of action of the force. We need H. So therefore, calculate what is H value. To get H value, what you do? See, to get the value of H, what you have to do is, see here, to get H value, consider triangle, of course, right angle triangle, ADE. ADE. Don't tell me, sir, last time you told not ADE, last time you told DEA. Don't come to my class, I will tell. Who will remember what I told last time? ADE. Okay, there, see here. If this is 30 degrees, you should write this angle is 60 degrees. Why means I can't explain. If that is 60 degrees, this angle is also 60 degrees. That much common sense requires. Or this angle equal to 30 degrees. Now, I want to get the value of H using AD value. Connect here. So if you want, you can write what? Connect this with this. If you use 30 degrees, what happens now? See? Connect them. Cos 30 equal to AE, which is nothing but your H. AE divided by hypotenuse is AD. Divided by AD. Why? Because 90 degree here. A. Or if you use sin 60, instead of cos 30, if you use sin 60, it is once again AE divided by AD. AE divided by AD. Any one will do. Okay, leave it. We will go for this one. Any one will do. Both are same. Sin 30 equal to cos 60. People are knowing it. Okay, now, if I go further, stop writing. Ink is little faint. I'll change the pen. Okay, now start. Therefore, to get H, we need what value? We need what? We need AD. We need AD. This also is not writing. Okay, new one. We need AD. Last time was same thing. To need AD, see, to get AD, first find BD. First find BD. Last time your D was below, now it is above BD. Okay. How to get BD? Consider triangle. Of course, right angle triangle only. Right angle triangle, see, this one. B, this is C point, CBD. Right angle triangle, CBD. If you want to use this angle or this angle, whichever you want, those who want this angle, tell what you are right. Sin 30 equal to BD divided by BC. BD divided by BC. BC is 160. Therefore, you get the value of BD. BD will come 92.3760 millimeter. Or some may use 60 degrees for them, or cos 60 equal to, see here, for this triangle, this is hypotenuse, cos 60 equal to BD divided by BC. BD divided by BC. BC is 160. This also will give same answer. My guarantee. What guarantee? Sin 30 equal to cos 60. Okay. Someone will tell guarantee is giving such a simple mathematics. Okay. Done. Over. Now we got the value of what? We got the value of BD. Now see. Then, but what we want? To get H, what we want? To get H we want, we written here. To get H we require, where I wrote it? We need AD. Therefore, AD equal to, see here, your A to D equal to A to B minus D to B. D to, or you don't think H equal to D to B. That much you can make out. A to B minus, I want what? I want, see, I want this AD. To get AD, this AD equal to A to D minus D to B. A to B is 200. Why? Original question, see there. Original question, see there. A to D is 200. B, D to B or B to D, just now we got how much? Just now we got 92.3760 millimeter. Therefore, subtract, your AD will come, where is AD? AD 107.624. 107.624 millimeter. Okay, A to D over. Once you get A to D, second question, Okay, now, therefore, I will tell here, H, substituting in, where, see here, sin 60 equal to, sin 60 or cos 30, anything, or whatever, we have decided cos 30, okay. Cos 30 equal to AE divided by AD. Your AE is nothing but H. See here, A to E is nothing but perpendicular distance H. A to D is just now you got it. How much? 90, 107. 107.624, just now we got. Therefore, your H equal to 93.2051. 93.2051 millimeter. 1 minute now. Let me check the camera there. I am coming too down. Hope it will not disturb. Oh no, plenty of space is there. Okay, okay. Plenty of space. Over, H over. Therefore, last statement now. Where should I write? Okay, this all I will remove now because we got the value of H. Now, no construction required. No construction required. Directly I'll go to the answer now. Nothing. Therefore, moment of 80 Newton force about A equal to, see here, 80 into H by basic concept, by basic definition, 80 into H or 80 into H equal to 93.2051 equal to 7456.406 Newton millimeter. And very important, see here, see last time, see correctly, the force was somewhere here. It was clockwise, but this time if you hold at A, your force is here, it will create anti-clockwise. So that much anti-clockwise. Over. All over now. Now I will do one thing now. I will put the result somewhere here. This none of them required now. See, everything gone. Full gone. I will write the answer here. Therefore, note, a little note, okay, here also. Note, by basic definition, that is you write here. What is basic definition? Moment of a force about any point is force into perpendicular distance. No resolution. By basic definition, moment about A is, we got, you write here, definition, we got. Not you got, I got, okay. We got, okay. Actually, I should write I got. You still get it. We got moment about A. Some will ask, moment of what? What is this? All this time I am telling moment of 80 Newton force. Again you want to waste time. Moment of that 80 Newton force about A. Our answer is, where is the answer? 7456.406 Newton millimeter, but remember anti-clockwise. This is the answer we got by basic definition. This you got for first question, this for second question. Now do one thing. Now I will clean the board and make ready for resolution. Question will be over within 1 minute for each, not 1 minute. Those who got high speed, half mean 30 seconds for each question or one question. If you resolve, maybe 30 seconds. I will make ready. Start. Now, class, I am dictating something for both the questions. You should write here, see right mark, same right mark there also required, if you are serious. Option 2, by resolution. Instead of struggling all that force acting here, where it will cut to perpendicular distance, etc., struggling we got, you can get the answer very, very easily by replace the given force of 80 Newton by its components, one in horizontal direction, say xx, other vertical direction, say y, right here. Let us consider x, y like this. That is by resolution. Let us resolve the 80 Newton force into two components along x, y right here. X horizontal, y vertical. Up to here, same for that question also. Now do one thing, don't see there. Now see only question 1. Question 1 continued. 80 Newton force here, passing to point C. It makes, they told 70 degree with vertical, but I told you 1000 times earlier, take with horizontal, 70. 20 with vertical, 70 with horizontal. So, components are like this. I should not explain now. This component is 80 cos 70. This component is 80 sin 70. I already calculated. First of all, I need not waste time explaining all this. Waste of time explaining. It is done so many times earlier. If it is not clear, you are not studying anything. Okay, start. Now, what we want? Moment of 80 Newton about A we want. But you know the principle. Moment of 80 Newton about A is algebraic sum of moments of the components about the same point A. 1 minute now. This comes from Varignon's theorem. It will come little later. Today you believe me. Today actually it comes by Varignon's theorem. So it is still not covered. Right now you write here. He told something. Moment of the force about any point is algebraic sum of the components of moments about the same point. It is actually by Varignon's theorem, which is to be proved. It will come next class only, not next class, another 2 class it will come. Till that time you write, we will believe him. Okay. Equal to start. Moment about A. Now do one thing. To understand correctly, put one more sketch here. See, A. Replace this force. Let us replace the given force 80 Newton by components. Okay. Now see, this is 160. This is 200. Moment about A equal to, see here, 75.1754 in, see, vertical force into 160 clockwise. This is clockwise. So I am taking clockwise positive. When you go for algebraic sum, you require sign. Remember, make a note. This all will come in the further classes, but people are knowing it. Clockwise plus. Then 27.3616 into 200 is anti-clockwise minus. When you calculate these two, I am so sure answer will come plus 6555 point. Maybe little decimal may change because of approximation. Let me check it. Okay. See, but remember, I am not in tension. 160 minus 27.3616 into 200 equal to, oh, same, 6555.744. 744 Newton millimeter. Remember, positive came. Positive sign means what we considered is correct. Therefore, final answer, I will write here now. Where? Okay, right here. Therefore, space problem. Okay, right here. Therefore, moment of final answer, moment of 80 Newton force about A, right, by option 2. By option 2, that is by resolution principle, we got no plus now 6555.744 Newton millimeter clockwise positive plus came that much clockwise, right? Oh, see here, same answer we got. Therefore, question 1 perfectly over. Now go to question 2. Okay. I will do one thing now. I will just rub the unwanted part. This question I will remove. This is not required now. I want space. This is not required. This is not required. This answer also not required. Verified. Okay, now. Once again, same statement you are right. Then go for resolution. See here. Now, second question, second question, see here. In the second question, that question, 80 Newton is this way. 80 Newton. Angle given is 60 with vertical means 30 with horizontal. Okay. So this is 30 degrees. This is all known for you. 30. So what happens now? 80 sin 30. 80 sin 30 is 40. I don't have to calculate. 40 Newton. Other is 80 cos 30. 80 cos 30, I think I calculated 80 cos 30. Where? I calculated 69.21, sorry, not fully visible there. Okay, I'll check once again. 80 into cos 30. 69.2820. 69.2820 Newton. Therefore, now replace the given force system by second. I am doing second question. Horizontal component of 69 point. Once again, you are right. 2820 Newton. Vertical component of 40 Newton. Distance remains same. Therefore, moment of 80 Newton force about A equal to algebraic sum of moment of the component same. Once again, clockwise positive. If you take clockwise positive, see what happens now. 40 into 160. 40 into 160 is clockwise. This all I will explain to you. Clockwise, so plus, then 69.2820 into 200. But that is anti-clockwise, minus. When you calculate, I'll check it. 40 into 160 minus 69.2820 into 200 comes to, negative, minus 74, I am not seeing the answer there, 56.4 Newton millimeter. This answer I got. Therefore, write the answer. Therefore, by option 2 for question number 2, option 2, that is by resolving our answer, moment of the 80 Newton force about A equal to minus km means what? See, we took clockwise positive, negative km means no minus now, 7456.4 Newton millimeter anti-clockwise is the answer. Oh, 406.006 difference or 0.06 difference in how much? 0.006 difference in 7,000, 0.06 in 75, around 75,000, 0.6 difference in 7,50,000 rupees, or 7,50,000 means 75 lakhs. In a transaction of around 75 lakh rupees, 6 rupees difference. Someone will tell, what is you are telling? It is not a difference. Okay, done. Therefore, perfectly tallying. Okay, now class is over, but before that ending, I will give an interesting question. It's a homework for you, briefly homework. Very interesting question, because I will tell you why interesting. I don't want to waste the time by going there, pausing and rubbing. I will use the same rub here and do it, because the usual that paper, rough paper for rubbing, it is not available. I displaced it or misplaced it. Therefore, I should struggle here. Okay. Some will tell, see, I'm struggling for rubbing. What to do? These are all part and part. These things all does not have any effect on standard of the class. See, I already told you, I never believe in what you show off or standard pattern, very, very neat, no dust, nothing like that. Okay, see, question 3, right here. Question 3, very, very interesting question. Same type of question. One member here. Inclined force, once again 80 only. No, I don't want to take 80, something else. 60 Newton. 60 Newton. And see here, this is 60 Newton given, 60 Newton for angle I am not giving. I am giving slope of the line. This is 3 and this is 4. Okay. ABC. ABC. This is, now I should be careful. This is 400 millimeter. This is 300 millimeter in the question given. Okay, start. Find moment of 60 Newton force, given 60 Newton force, right here, the given, not visible, okay, 60 Newton. 60 Newton force about A. About A. Okay, first do one thing. First do by basic concept. Basic concept means right here, from the point A, we have to drop a perpendicular to line of action of the force. Same as last time questions. Before that, you need what? What is the angle for this? You should decide what? See, you should decide when you extend this force, will it cut this line above A or below A? Make a note. Before you drop perpendicular, first you should know when you extend, will it come somewhere here or somewhere here? What to do? You find this angle. This angle is theta. This is 400. This is 300. No. Okay, 300. Or why to 400, 300? I will change the values, not worse. 800, 600. Same number should not come. 800 mm and 600 mm. Otherwise, some will tell same ratio. Okay, 600 mm. Okay, this is 800 millimeter. This is 600 millimeter. Theta equal to tan inverse of 800 by 600 equal to, there's a calculator I kept. I was having here. Shift tan inverse of 8 by 6. 8 by 6 equal to something wrong. 8 divided by 6. It's some other mode. Okay, mode 1. It has gone some other mode. 8 divided by 6. Shift tan inverse answer. 53.130 degrees. It is 53.130. 130. Where is the answer? 8 divided by 6. 130, 10235. 10235 degrees. Okay. Now, start. Now you require angle for 60. See, for 60 Newton force, again angle not given. So see here, 60 Newton force is here. We want angle for 60 Newton, for 60 Newton force. We want angle with horizontal. Say that is theta, let it be alpha. Let it be alpha. Okay. But they told this slope is, this is 3, this is 4. See, if this is alpha, this also is alpha. Therefore, alpha equal to tan inverse of 4 by 3 equal to 53.130 degrees. Oh, what is this? What angle this C to A joins makes with horizontal, same angle is made by 60 Newton force also with horizontal. Oh, therefore, right here, theta, therefore alpha we got equal to theta. Remember, right here, coincidence. It is very, very coincidence. Special question I told. Oh, therefore, if I draw a line here and draw here, if I mark that force here, it will, see, it will correct, see, it will correct, one thing now, okay. Or 4:3. See, if I join this A, B and C, join this line here by dotted line, force also will act along the same line. Coincidence, a 60 Newton force. Now, we want moment about A. Moment about A. For that, what you need? We need perpendicular H from A to line of action of force. But line of action of force passes through A. Of course, coincidence. Therefore, perpendicular is not there, or you can tell, see, this point A unknowingly lies in the line of action of the force. Write that reason, right? Therefore, moment of 60 Newton force about A equal to 0. Right there. Now do one thing. Solve by resolution. Okay, let's see by resolution. If you solve resolution, see, this is not required. This is not required. But this is required. Okay. Right. Once again, right here. Now, option 2. Option 2. By resolution. This pen is not writing. I have to search for a new one, not getting here. Okay, I will use the available one. I will somehow manage it. Closing part. Okay. Start. Now, 60 Newton force is this way. See? This way. 60. Alright, one thing. Through the point C, 60 Newton force is acting here. It is making an angle with horizontal of, just now you got alpha, how much? 53 point, that is alpha, okay, let it be alpha only, alpha. You write alpha is already known to you. How much alpha? 53.13010.235 degrees. This will be equal to a horizontal left component, see here, left component, vertically down component of, I won't waste time, 60 cos alpha, this is 60 sin alpha, 60 cos alpha is 36 kilonewton, 60 sin alpha is internal 48 Newton. I know it. Then replace by components. Vertical component of 48 Newton, horizontal component of 36 Newton. This height is 800 millimeter. This base length is 600 millimeter. A, right here, I won't write algebraic sum of moment of the component, or moment of the given 60 Newton force about A equal to algebraic sum of moment of the components about this point A. This all I told just now, right here first, systematically right, equal to, we will take clockwise positive, 480 into 600, that is clockwise positive, minus 360 into 800 equal to, actually wasting time. I know the answer, 480 into 600 minus 360 into 800. Question set by me. No, calculator is not responding. 0. It has to come 0 because you know, even after resolving, if for original force, when you do by basic principle, if some moment comes, same should come here. This is a bonus question. Make a note. Or now confirmed what? If the point lies anywhere in the line of action of the force. See, first question what happened is, this force was steep. See, it was this way. It was coming somewhere here. Perpendicular was there. Second question is this way. It is cutting somewhere here. Perpendicular is there. This question, it is correctly passing through A. Therefore, moment came 0. Today's class is only for understanding. Tomorrow's class is very, very important because I am going for multiple force system this way, many forces. Of course, I will give inclined forces, I will resolve it. Finally, you will get a force system for, we have to find algebraic sum of moment, very, very important. That is what very thoroughly you have to cover. It may take around 1 hour to explain because I will find moment about A, moment about B, moment about C, moment about D, and moment about one more point. Just for thorough understanding, because next you are going for coplanar force system resultant, there moment will come. Okay, now go through everything thoroughly, be ready for next class, that is 21, where I will start multiple forces, but by resolution. Thank you.